Now the staff can manage the system by making the entire process faster, smoother and more reliable. Next, for the objective, where the objective is to study ability and function of the system and then compare the manual system, design and develop the user-friendly system, and then test and deploy the management system. Next is for the use case diagram. As we can see, staff they can log in and manage the reservation and then log out. And then for the customer, you can log in, register and making the reservation and then log out. Next, for the system requirement specification. For the functional requirement, customer function can register account, view venue list, create and cancel booking, check reservation status and edit profile. For the staff function, can log in into the staff dashboard, view and approve the reservation, edit staff profile. For the non-functional requirement, the performance, load a venue data less than 3 seconds, security, have a role-based access only, visibility, have a simple and user-friendly UI, availability, have a 99% uptime and minimum downtime, scalability, can handle more user and booking. So the system module overview have a login module, profile management, reservation module, and lastly venue search module.
My name is Nur Akila binti Zul Ahmad Tamizi. My matric number 074522. So before we go into the actual flow, the system first defines the basic components we will be working with. We declare some unique identifiers like staff ID, customer's ID, venues and reservations ID. The system also defines the status of a reservation, which can be either pending, approved or cancelled. These definitions act as the foundation for how our system will operate. Once the basic terms are declared, we describe the state of the system through the main schema called eVenue. This is like a snapshot of what exists in the system at any moment. It includes the list of all staff, customers and venues and a record of all reservations that have been made. We also store each user's profile information and track who is currently logged in. But clearly organizing this structure, we make sure the system always knows who is using it and what data belongs to who. The first real action by staff member is to log in. The system will check whether the given staff ID is valid, meaning it already exists in the list of registration staff. This login process is important to make sure that only authorized staff can perform staff level operations like approving reservation. After login, a staff member may want to edit their profile, such as updating their contact information. The system will check whether the staff ID is valid. If it is, their existing profile is updated with the new information provided. Next, staff may want to view reservations made by customer. To do this, the staff simply inputs the customer ID. The system will then find all reservations made by that customer and display the details, including which venue was booked and what the current status is. This helps staff understand customer activity and supports them in handling any requests or problems. The theorem confirms that our view customer reservation schema is valid within the system. It ensures two things. First, the customer ID use must exist in the system. Second, the output, the reservation status must be correctly structured. The expressions view customer reservations to eVenue simply means these operations won't break the system consistency. So anytime staff views a customer's reservations, the system remains stable and correct. One of the most important roles of the staff is to approve pending reservations requests. When a reservation is made by a customer, its status is set to pending. The staff will review the request and if everything is valid, they approve it. The system will then update the reservation status to approve. This step ensures that only valid and appropriate bookings are confirmed, preventing double booking or misuse of venues. The theorem confirms that approve is a valid status in the system. It ensures that when staff approve a reservation, the status used is correct and won't break the system rules. Once the staff has completed the task, they can choose to log out. This action removes the ID from the list of currently logged-in users. It ensures the session is securely closed and that no unauthorized actions can be taken after the staff member leaves the system.
My name is Yasmin binti Shanul, matric number 074606. Next, we move to customer schema. First, customer registration schema. This schema handles customer registration. It will check whether the customer ID already exists. If it doesn't, the customer is added to the system. The theorem here validates that the input must be a valid customer from the defined customer set and confirm the system state is correctly updated. This is to ensure that only valid registration go through and duplicates are avoided. This slide shows how login and logout work. For login, if the customer exists, they are added to the login list. As for the logout, they will remove from that list. The schema only change the session state. They don't affect the actual customer data or booking, which keeps everything else safe. For edit customer profile schema, the schema allows a customer to update their profile information. So it will check that the customer exists, and if so, it will replace their old profile with the new one. And then the rest of the system stay unchanged, which keeps the update focused and prevent error. Next, search available venue schema. This schema is used to view available venues. It's a read-only operation, meaning it doesn't affect any part of the system. And then the theorem in the schema confirms that the output is a valid subset of the venue set. This is proof that the venues shown to the user are accurate and officially stored in the system. For make reservation schema, this schema lets a customer make a new reservation. It first checks the customer, venue, and reservation ID are valid, and the ID isn't already in use. So if everything is valid, the system creates the reservation with a default status of pending. The theorem in this schema validates that the input types are correct and the state is updated safely. This is to help prevent double bookings and keep the data consistent. Next, view reservation status schema. This schema allows a customer to check a status of their reservation by ID. It verifies that the reservation exists and then retrieves its current status. The theorem for this schema ensures that result belongs to the status set, such as pending, approved, or cancelled, which keeps the status output reliable and controlled. Lastly, cancel reservation schema. So this schema is used to cancel a reservation that's still pending. Once the system confirms it's valid, the reservation status is updated to cancel. This theorem proves that cancel is a valid status in the status set. This is to protect the reservation data and prevent the system from accepting invalid status changes. In summary, the system requirement specification outlines how both staff and customer interact with the e-venue reservation system. It includes key actions like login, profile updates, venue viewing, and reservation handling. Formal specification and theorem validation help ensure that each function operates correctly and securely. And it also maintains data consistency and supports a reliable system for all users.